Good evening and welcome to Infinity and Beyond. My name is Caitlin Morano and I will be your host for this evening. On tonight's show, we have our special guest, the most talented Western mathematician of the Middle Ages, my friend and yours, Leonardo Fibonacci. Hello. Hello there, Leonardo. How are you doing on this fine evening?
Hello to you, Caitlin. I am doing quite well. I am just so excited to be here.
As are we, Leo. As are we. You don't mind if I call you Leo, do you?
Well, I'd rather not.
Great. So, Leo, tell us a bit about yourself.
Okay. Well, I was born in 1170, a long time ago. Still alive. Crazy. Kidding. I'm dead. Alright. My father, Guglielmo, he is a wealthy merchant, and I used to travel with him as a boy. Just got long hair. One time, I went with him to Bugia, and that's where I learned all about the Hindu-Arabic numeral system.
And is that what you discuss in your new book, Liber Amici?
Wait, you haven't read it.
Never mind that. Tell us more about this book.
Well, anyway, the numeral system. As I mentioned before, I introduced it to Europe. Because it is just so much easier than Roman numerals. I can show you in a minute, but you'll see that it's made up of 10 digits. And with these 10 digits, you can combine them to make any possible number.
Well, aren't you going to show us what these 10 digits are?
I will. All right. These 10 digits, we start with 0, 1 digit. And we have 1, 2, 3, 4, 5, 7, 8, and 9. With all these numbers, we can create any number imaginable. For example, I can take 7 and 1 and create a whole new number.
Wow.
71. Much easier than a bunch of dashes.
Yeah.
You can even create larger numbers. I can take the number 6, the number 2, and number 4. Now I have 624.
That's amazing.
Much easier.
It is. That is just fascinating. Oh, I don't want to run out of time before the end of the show. I would really love to learn more about this Fibonacci sequence I've been hearing all about. Would you mind to give us a little lesson in it?
I would not mind at all. It's quite easy, really. Simple mathematics, if you think about it. You see, we start with the number 1, just as we did in these new numbers that we found from the Hindu-Arabic system. With that, you follow it by the number 1. I'll show you. With the number, after we write down 0 and 1, we are going to add these two numbers. We're going to find the sum of them.
Okay.
So if we start with 0, continue with 1. These are the first two numbers in my system. What we're going to do is we're going to find the sum between these two numbers. We're going to write that next in our sequence. So 0 plus 1. And then we're going to follow the sequence. So 1 plus 1 is 2. Alright? And if you keep following this pattern, you can continue to find future numbers. So for example, we take 2 and 1.
That would be 3.
3. And this pattern keeps going and going and going. So,
is there any rule that we could follow to try to make these calculations a little easier?
there is a rule. The rule is you're going to use x sub n equals x sub n minus 1 plus x n minus 2.
Okay.
With this rule, if we have a table where we have the numbers written out, we can assure that the system, the pattern, is following itself. So if it checks out, we're golden. So for example, if we wanted to find the 9th term, we would start with x sub 9. We're going to plug 9 in where we see n. So we're bringing the x with us. There's an n here. We're going to bring the 9 down, subtract 1, bring the plus sign. Same thing, plug in the 9, minus a 2. Just going to simplify these. I know you're new to these numbers.
Yeah.
I'll help you, don't worry. Again, bring down the x sub 9. We have x, 9 minus 1 will give us 8, plus x, 9 minus 2.
7.
All right. with these, we will be able to find out the 9th term. We are plugging in the 8th term. We're not plugging in the number 8. We're going to figure out what the 8th term is. We're going to add that to the previous number, which is x sub 7, so the 7th term. These two combined give us the 9th term.
Okay.
Sounds like a lot. It's not. Promise.
All right. I trust you.
So, if we know that the 8th term is...
Well, let's go through. We have 1, 2, 3, 4, 5. Next one would be 5. 8. 13. That gives me 1, 2, 3, 4, 5, 6, 7, 8. Okay, our 8th term's 13.
These numbers represent the subterms.
Okay.
So, we have the sub, x sub 8 is 13. So we can plug that in. 13. Bring the plus sign. We have x sub 7, the 7th term is 8. We combine these two numbers. X sub 9 equals 21. And we can also see in the pattern, if we take 8 plus 13, the two terms next to each other, gives us 21. A lot of information.
It is.
Would you like a whack at it? So, I were to give you x, I wanted you to find the 11th term.
Okay.
What was the rule? What can we plug in? What do we know? We know the x. We know that...
It would have to be 11 minus 2.
Almost. There's two terms.
11 minus
So,
1.
There we go. It's us mathematicians. We're good at this. 11 minus 1. So this term is going to be 11.
That would be 11
minus 2. All right, bring this down. 11 minus 1 is?
That would be 10.
Plus x, 11 minus 2?
9.
All right. I'm just going to back this up so you can see our sequence. Usually you'll have some type of table to help you out because you will not be able to plug these numbers in unless you already have them.
Gotcha.
So that's why it's not a formula exactly, it's just a rule to guide you through it.
Okay.
So we knew that the 8th term was 13. 9th term, we found out previously, was 21. 10th term, you can combine these two. 13 plus 21 is 34. And up to here, we can use this rule. So what information will we be plugging in?
34.
And then the 9th term?
21.
All right. You're going to plug these in, and the 11th term equals?
55.
All right. And we can look at the sequence again. 34 plus 21 gives us 55, and that is the 11th term. So as you see, checks out.
That is fascinating.
It is fascinating.
Yes. Okay. Before we end this segment, is there anything that you just want us to know that we haven't covered yet so far?
Well, since math is just so much fun, there are some fun facts that come with it. Well, one little information tidbit is the golden ratio. With my sequence, if you find two consecutive numbers, you will come very close to the golden ratio.
And what is this golden ratio?
The golden ratio is a term that we use. It's a mathematical term. And it's based, I know math, crazy. The golden ratio is basically what mathematicians use when you have a line. If you were to separate the line, the smaller half divided into the bigger half will give you this number.
Okay.
The golden ratio approximately is 1.61. Now this is just an approximation. It's like pi, it goes on forever. So what we have to do in our Fibonacci, in my Fibonacci sequence, I'm taking ownership, we're going to take 2 consecutive terms. So we can start with, we knew the first term was 0, second term was 1, third term was 1, fourth term was 2, fifth term 3. I like these 2 numbers. We're going to use these 2.
Okay.
These 2 are consecutive, right next to each other.
Mm-hmm.
All right? We're going to take these 2 numbers and find their ratio. So we're going to take the number 3, divide it by 2, and that's going to give you 1.6025. We can double check. 2 divided by 3 goes in 1 time. I lied. Just keeping on your toes. Gives you 1.5. Just making sure you guys are on your feet. From this, you can see it's close, not exact. It's pretty close, pretty close. We can take even larger numbers.
Yeah.
I won't bore you by drawing the whole Fibonacci sequence out because you will be here for a while. But I can tell you, down the road, there are 2 consecutive terms. You have 233.
Yeah, we can take 377.
Okay. And 377. These 2 terms,
Okay.
right next to each other, consecutive, they're not just random numbers.
Mm-hmm.
Consecutively. Just like before, this is the first number and this is the second number. We're taking the second number and we're dividing by this number. So we have 377 divided by 233. 377 and 233 is approximately 1.625. 8. So compared to the original of 1.5 was close. It was close, can't lie. This one,
That's much closer.
even closer.
It is.
All right? So as you can see, the larger you get, the closer these numbers are, the larger these numbers are, the closer you're going to get to the golden ratio.
Wow. Okay.
All right? Just going to clean your board for you.
Oh, thank you. You didn't have to do that.
I'm just so nice.
That was quite the fun fact, Leo. Thank you for being with us tonight and sharing all of this with us. Well, that seems to be all the time we have for today. Thank you for watching, and we sincerely hope you enjoyed this episode. Until next time.